Stretching across the Asian continent is a formidable 2,500-kilometer wall of solid rock and glacial ice. At its center sits Mount Everest, towering almost 9 kilometers into the atmosphere and holding the title of the highest point on Earth. These peaks have dominated human culture for millennia. According to ancient texts, summits like Mount Kailash serve as the sacred dwelling places of the gods. But while these mountains feel eternal to us, geologically speaking, they are the youngest mountain range on the planet. If you were to rewind the clock roughly 100 million years, you wouldn't find a single peak of ice and rock here. In fact, you wouldn't even find the Indian subcontinent beneath them. As this map of the ancient Earth shows, right where these freezing high-altitude summits stand today, there was only a vast, warm body of water known as the Tethys Sea. This leaves us with a massive physical contradiction. How did the highest points in the sky rose up from the bottom of an ancient ocean? To find the answer, we have to look far to the south. Looking at this map of the supercontinent Gondwana, we can see that over 100 million years ago, the landmass we now know as India was physically attached to Africa, Antarctica, and Australia. Eventually, the tectonic plate carrying India broke away from this landmass and began a long drift northward across the open ocean. Tectonic plates usually move at a slow pace of around 40 kilometers per year, but the Indian plate rapidly accelerated, hitting a speed of 150 kilometers per year as it ran towards Asia. After tens of millions of years of open water, the landmass ran out of room. Roughly 50 million years ago, the speeding Indian plate smashed into the massive Eurasian plate. This unstoppable impact initiated a geological event that would rewrite the map of the planet. Looking at this cross-section of the Earth's crust, we can see the mechanics of the impact. Because both continents were composed of light rock, neither could easily sink into the Earth's mantle. Instead, the momentum of the Indian plate forced it to slide directly underneath the Eurasian plate, a process called subduction. As the plate wedged itself deeper, the pressure took the sediment resting at the bottom of the Tethys Sea and crumpled it upward, folding the ancient seabed into the sky. We know this because the evidence is locked inside the rock. Today, climbers thousands of feet up in the freezing air routinely discover perfectly preserved marine fossils, like this ancient trilobite, embedded in the peaks. Look closely at the rock walls near the summits, and you will even find the fossilized ripple marks of ocean waves permanently etched into stone that now touches the clouds. The roof of the world is the grainyard of an ancient sea, elevated into the stratosphere by the force of moving continents. As this weather model shows, this newly formed wall of rock reprogrammed the region's climate. The immense height acts as a physical shield, deflecting freezing winds from Eurasia and keeping the Indian subcontinent warm. At the same time, these peaks catch moisture-heavy monsoon clouds blowing in from the oceans. The resulting heavy snowfall compresses over time, forming the largest glacial system on Earth outside of the polar regions. These massive glaciers essentially function as a water pump. As the ice slowly melts, it feeds perennial river systems, including the Ganges and the Brahmaputra. As these rivers flow southward, they carry nutrient-rich silt, depositing it across the plains. This supply of water and fresh soil turned a historically dry expanse into some of the most fertile agricultural land on the planet. With a reliable water supply and abundant harvests, early humans were able to settle permanently. This agricultural stability enabled the rise of complex societies like the ancient Indus Valley civilization. The Himalayas function as a foundational life support engine, sustaining billions of people across Asia today. This geological engine also forged highly specialized, isolated ecosystems. At extreme altitudes, thick layers of insulating fat allow rare predators like the snow leopard to thrive in the harsh cold. Further down, in the lush, mist-filled valleys of the lower range, the moisture supports a different kind of biodiversity, serving as a sanctuary for endangered species like the red panda. The Indian plate never actually stopped pushing. The tectonic collision that started 50 million years ago is still happening right now, triggering earthquakes and driving these peaks millimeters higher into the sky every single year. The Himalayas are a restless, living machine, actively engineering the future of our planet.